Hello, this is Mr. Stansbury. I'm going to take you through the 9F assignment. All right, let's start with number 1 here. Which of the following are quadratic functions? So in order for it to be a quadratic function, the highest power has to be, the highest x power has to be squared. So since that is a x squared, a would be a quadratic. This highest power is actually x to the first, which makes it linear, not quadratic. Highest power is x squared, so that's quadratic. Highest power x squared, that's quadratic. Doesn't matter what the coefficient is on any of those. And then this one here, even though there's a y over here, as long as the highest power of x is x squared, then that is a quadratic. And this highest power is third, so that's actually a cubic. So it's a, c, d, and e are quadratic functions. All right? Moving on to number 4. State where the following quadratic functions are satisfied by the given ordered pairs. So for a here, we've got basically what we're going to do here is wherever we see x, we're going to plug in 0. Wherever we see y, we're going to plug in 5. Okay, and remember this f of x is the same thing as y, right? So for this one, we get 5. Does 5 equal 5 times 0 squared minus 10? So that's going to be, does 5 equal 0 minus 10? No, it does not. So it is not satisfied by the given order pair. Okay. B, we've got y equals, so here's our x, there's our y, so we've got 9 equals 2 times 4 squared plus 5 times 4 minus 3. Okay? So we get 9 equals 4 squared is 16 times 2 is 32 plus 20 minus 3, and that's going to be what? 52 minus 3 is 49. This one also is not equal, so that doesn't work. Okay, C, y is 1. Does 1 equal negative 2 times negative 1/2 plus 3 times negative 1/2? So we got 1 equals, negative times negative is positive, half of 2 is 1, and then that's minus 1.5. So 1 does not equal negative 0.5, so C doesn't work either. And then let's take a look at D. Excuse me, we've got, let's see, this here is our y, so we've does 16 equal negative 7 times negative 1 squared plus 8 times negative 1 plus 15. So negative 1 squared is 1 times negative 7 is negative 7 minus 8 plus 15. We got 16 equals 0, and that is not true either. So none of these work. Okay? But that's all you got to do is just plug in the x and y and see if it works. All right, moving on. Number 5. Find the values of x for the given value of y for each of the following quadratic functions. So again, we're normally used to plug in 1 in for the x's. Now we're plugging 1 in for the y here. So for a, we've got 1 equals x squared plus 6x plus 10. Okay, oops, that's a 10 there. We want to subtract 1 from both sides. Set one side equal to 0, plus 6x plus 9, and then now we're just going to factor this one. Leading coefficient is 1, so it's going to be x times x. Factors of 9 that add up to 6. 1 times 9, or 3 times 3. 3 times 3 adds up to 6, so I'll put 3 and 3. They have to add up to positive 6, so they're both going to be plus. Okay, so remember, this is, since there's an equals, we actually have to come up with what x equals. So x will have to equal negative 3 plus 3 gives us 0, and negative 3 plus 3 gives us 0, so it's just plain old x equals negative 3. Okie dokie. B here, we've got 2 equals x squared plus 5x plus 8. So subtract 2 from both sides, and we get 0 equals x squared plus 5x plus 6. So now we're coming up with the factors we want to come up with the factors of 6, which are 1 and 6, or 2 times 3, that add up to 5. So 2 and 3 add up to 5. 2 and 3. And in order for these two numbers to add up to positive 5, they both have to be positive. So x would then have to equal negative 2 plus 2 gives us 0, or negative 3 plus 2 gives us 0. So either one of those would solve that, would make it when y equals 2. Okay, C, we've got negative 3 equals x squared minus 5x plus 1. Add 3 to both sides. And we get 0 equals x squared minus 5x plus 4. So now we want to try to come up with factors of 4, which are 1 and 4, or 2 and 2. Which ones of those add up to 5? And that's going to be 1 and 4. 1 and 4. So then we just have to look at what signs we have to put in here so that when we add them together we get negative 5. It have to be negative 1 and negative 4. So x would then have to equal 1, because 1 minus 1 is 0, or 4 minus 4 is 0. So those would be our two solutions for that. All right, D, we get negative 3 equals 3x squared. All right, so since you don't have that x term, let's just do this. Let's just divide both sides by 3. Negative 1 equals x squared. So then we square root and say, uh-oh, can't take the square root of a negative. So no solutions. Okay? Okay, so that's what we end up with for that one. Let's move on to the next one. Number 10, find the values of x given that f of x equals 5, so forth and so on. So again, this is the same thing as putting y. This is y equals 5, y equals 1, y equals, which, and again, these are all y's also. The whole thing is just y. F of x is the same thing. So a equals, now we have, oops, not equals, letter A. We've got 5 equals 3x squared minus 2x plus 5. Subtract 5 from both sides, and we get 0 equals 3x squared minus 2x. Okay? So, if you'll notice here, we can get an x out of both of these. So let's divide, let's factor an x out of both of those terms, and we get x times 3x minus 2. Okay? So then x would then have to equal 0, because 0 times anything will give us 0. Or, remember this is where we take the opposite of this number, positive 2, divide by whatever number's in front of x, 2, not halves, but 2/3. So 0 or 2/3 would work for A. Okay? B, we got 1 equals x squared minus x minus 5. So subtract 1 from both sides. 0 equals x squared minus x minus 6. So we got to come up with the factors of 6, 1 and 6, or 2 and 3, that have a difference of 1. So 2 and 3 have a difference of 1. So we do 0 equals, we got x times x, and then we'll put 2 and 3 in there, and then we know these have to add up to negative 1. So I'm going to put negative 3 and positive 2, because I know that that adds up to negative 1. So x will then have to equal negative 2 plus 2 is 0, or positive 3 minus 3 gives us 0. All right? All right, C, negative 17 equals 2x squared minus 12x plus 1. Let's add, oops, not 18, but 17 to both sides. We get 0 equals 2x squared minus 12x plus 18. Now, what's going to really make this a lot nicer of a problem is to factor a 2 out of all of these, because all these have a factor of 2, right? So let's do that. I'm going to move this down a little bit so it looks a little better. So we got 0 equals, and then we got a 2 out there, and now it's just x squared minus 6x plus 9. Okay? So now we got to come up with the factors of 9 that add up to 6. So 1 and 9, or 3 and 3. 3 and 3 add up to 6. So we got 0 equals 2 times x and x, 3 and 3. They have to add up to negative 6, so it's going to be negative 3 and negative 3. So x would then have to equal 3, because 3 minus 3 is 0, and also 3 over there, so it's just x equals 3. Okay, moving on, number 7. An object is projected into the air with a velocity of 30 meters per second. In height in meters, after t seconds, it's given by the function, this function here. Calculate the height after 1 second, 5 seconds, and 3 seconds. So let's do that. So this here is the time, so we're going to plug that in for the t. So it's just going to be the height at 1 second. Again, this is this formula here, equals 30 times 1 minus 5 times 1 squared. Okay, so the height at 1 second is going to be 30 minus 1 squared is 1 times 5 is 5, so 30 minus 5. So the height after 1 second is going to just equal 25 feet. Okay? Oops, and that's part 1 of A. Part 2 is after 5 seconds, so the height after 5 seconds is going to be 30 times 5 minus 5 times 5 squared. Okay, so we get h, height at 5 equals 30 times 5 is 150 minus 5 squared is 25. 25 times another 5 is 125. Okay, so the height at 5 is also, oops, not 125, but plain old 25 feet. Okay, so let's see, let's figure out what happens at 3 seconds. So the height at 3 seconds is going to be 30 times 3 minus 5 times 3 squared. So at 3 seconds, 30 times 3 is 90. Minus 3 squared is 9. 9 times 5 is 45. So the height at 3 seconds is 45 feet. Okay? So apparently just by looking at these here, excuse me, at 1 second it's up at 25 feet. And then at 5 seconds it's back down at 25 feet. And then at 3 it's at 45. So it looks like it probably starts at 0, obviously, and then you throw it, it's projected up, and at 1 second it's at 25. At 3 seconds it reaches its height, which is 45, and then it starts coming back down. And at 5 seconds at 20, it's back at 25 feet. Okay? B, calculate the times at which the height is 40 meters and 0 meters. So if we're trying to figure out how high it is, that's when we're going to plug 40 in for our y equals. So that's going to be take place of the h of t. So 40 equals 30t minus 5t squared. Okay. Now on this one here, we're going to want to get everything to one side. But since our squared is negative, I'm going to move everything to the left side instead of moving it to the right side. So I'm going to add 5t squared and subtract 30t. So add 5t squared and subtract 30t, and we get 5t squared minus 30t plus 40 equals 0. Okay, and then now we're going to want to try to figure this one out. Now, again, our life just got a little bit nicer with this because all of these have a factor of 5. So we'll factor the 5 out first. We get 5, and now we're left with t squared minus 6t plus 8 equals 0. So now we're going to factor this one here. T times t, factors of 8 that add up to 6. So let's see. Let's do that over here. 8. 1 times 8, 2 times 4. So which ones of those add up to 6? 2 and 4 do. So we got 2 and we got 4. And then in order for these two numbers to add up to -6, they have to be both negative. So t has to equal 2 or 4. So that means it was at 40 meters. Oh, I put feet on all these, so these apparently are all meters. Silly English guy. So those are all meters. So at 2 and 4 seconds. So at 2 seconds, it's at hitting 40 on the way up, and then at 4 seconds, it's at 40 on the way down. Okay. And so that was part 1 of B. Part 2 is 0 meters. So when does 0 equal 30t minus 5t squared? Okay, it's already set equal to 0, so let's start factoring stuff out. We can get a 5 out, and to make my life a little bit nicer, I'm going to just factor in -5. Actually, let's do a 5 and a t. Let's do -5t. So we get 0 equals -5t, and then we're left with, I'm going to put this out. It doesn't matter what we do. So let's just do -6 plus t, right? So t is going to equal -5 times 0 is 0, or -6 plus +6 is also 0. So when at 0 and 6 seconds is when it's going to be at 0. So that's right when it starts, and then it takes 6 seconds for it, apparently, for it to get back down to Earth. Okay, explain your answers in part B. Well, let's see. We kind of already did that. But anyway, this is at 2 seconds. At 2 seconds, it's at 40 meters, and it's going up. And at 4 seconds, it's at 40 meters coming back down. 0 seconds is right before it's launched, and 6 seconds is right when it hits the ground. Okay? All right. Number 8, cake manufacturer finds the profit in dollars of making X cakes per day given by the function, this function here. Calculate the profit if 0 cakes. So A part 1 is no cakes. So that's going to be, let's just do this. Profit is going to be -1/4 of 0 squared plus 16 times 0 minus 30. So 0 squared is 0 times -1/4 is 0. -16 times 0 is 0 minus 30. So the profit is -30 if you make, if 0 cakes, let's see, the profit in dollars of making 0 cakes per day. So if they don't make any cakes, they lose $30 a day. That's pretty good. It's not too bad for sitting there not doing anything. Well, I guess you lose $30, but anyway, so that's -30. Part 2 of A is 10 cakes, so the profit -1/4 times 10 squared plus 16 times 10 minus 30. So 10 squared is 100. -1/4 of 100 is -25. 16 times 10 is 160. And minus 30. So let's see, that's -55 plus 160 is $105. So you make $105 if you make 10 cakes are made per day. And I would imagine this, back to part 1, I would imagine that -30 is probably, lost, probably like baking supplies going bad or something like that. But anyway, B. How many cakes per day are made if the profit is $57? So now 57 goes in for P, and that equals 1/4, -1/4 of x squared plus 16x minus 30. So let's move our 57 over here. I know we got the -1/4. We'll take care of that in a second. -57. 0 equals -1/4 x plus 16x minus 87. Okay, now I really don't like the fraction in front here. That's not going to help us much. If it's a whole number, that's not so bad, but the fraction makes it a little bit less pleasant, and it's negative. So here's what I'm going to do. If I multiply both sides by negative 4. Multiply everything by negative 4. Negative 4 times negative 1/4 x is just plain old x, which will make it a lot nicer to factor. Okay, negative 4 times 0 is 0 still, right? Negative 4 times 16 is negative, I believe, 64x. Oops, and that's, oh, this is x squared, and this is x squared. And then negative 4 times negative 87, I don't know what that is. Let's figure that out. Okay, so negative times a negative is a positive, so 4 times 87 is 348, and that's going to be positive 348. Okay, so now we're going to try to factor this thing out. We know that that's x and that's x. We got to come up with the factors of 348 that add up to negative 64. That add up to 64. So that might take a little while. This one might be a good idea to plug into the quadratic. I mean, we're already here, so I'm going to keep on trucking, but way back up here, you could have just plugged all those numbers into the quadratic formula and solved that way too, but I'm sure 348 will eventually find us a couple factors that add up to 64. So just to kind of get a starting ground, I'm going to do square root of 348 and see if that magically gives us something nice. So let's see. I'm going to try 18 first. Because that one didn't work. 348 divided by 18 gives us 19. So let's try 348 divided by, say, 17. That doesn't work. 348 divided by 16, and we'll just keep trucking on this until we find something. I'm going to find something and then come back and let you know. Okay, had to do some, kept having to divide and stuff out to figure it out. We had 12 times 29, but that didn't add up to 64, so then I tried, I knew that 6 was a factor of 12, so I tried 6 and that, I did 348 divided by 6, and that gave me 58. So here we go, we've got 6 and 58. And we know that those two numbers have to add up to negative 64, so that's going to have to be negative and negative. So x would then have to equal 6 or 58. Okay, so if they made 6 cakes in a day, they'd make $57. If they made 58 cakes in a day, they'd make $57. I'm trying to figure out why. Maybe they just couldn't sell all those 58 cakes. But if I'm looking to make $57 a day, I'm shooting for making 6 cakes instead of the 58 cakes. Okay. Okay, so that's all there is for 9F. If you have any other questions, please ask in class. Thanks.